Hi, I'm Johnny Claridge. If you've called with technical questions, I may have been one of the ones you called to. Today, we're going to show you a part about doing cam timing, something that we've written about in length in our book. We still get a lot of phone calls, so I thought we would kind of lay out how we do it here and eliminate some of the myths about cam timing. So this is what this whole project here is going to be about. First myth I want to end is when you put a motor together and you line all your components up dot to dot, that's what you've done. You've lined all your components up dot to dot. That is a starting point for degreeing in the cam. That does not mean the cam is heads up. It does not mean it's what the lobe separation on your cam card says. It is strictly dot to dot. Your cam companies will all state you need to degree in your cam, and here's the reason why. Every component I've laid out here has variables. They have an area range they can hit. From this upper gear to this lower gear to the cam button to the crank keys. So you could have all these components only be off a degree or two, and then this cam be 10 degrees retarded. Motor wouldn't run very good 10 degrees retarded. Cam companies try to take advantage and save the base circle of the cam, and that's why the dial is located where it's at. This button might not be perfectly, if everything was perfect, where it would wind up 113. There's a variable involved. So another reason you have to degree in your cam if you're going to do this. Otherwise, you're just lining everything up dot to dot. You haven't done anything but get to a starting point in your project. I use this Reher-Morrison wheel for the simple reason, my old eyes, these big numbers make life a lot easier, but it also has the numbers of which you're gonna, when we start getting into degreeing, that are in black, that'll help you count backwards to help you degree, come up with your final numbers. We do this off a 50 off method. If you look at your cam card, they'll have advertised, and then they'll have at 50. We degree in all our cams. All our data is based off at 50. So there's several things you need to degree in a cam. Some people use a hard stop to find TDC. That's the first thing you have to do. It's important to find TDC and keep everything locked down until you get your pointer and balancer off, because everything is based off this first step you make. Your piston to valve, your cam timing, your ignition timing. If somebody bumps your pointer or you loosen your pointer or whatever happens, it throws everything off. So this is a very important project. I do it a different way than a hard stop to find TDC, but we'll get into that later. Gotta have a bridge. Gotta have a dial indicator. Of course, a degree wheel. So this is the part you're gonna need if you're gonna degree in your cam. If you're doing a cam change with the heads on, you have to build, I don't know if anybody even sells them, but we have a spark plug with a shaft through it to make a hard stop, so you can even do this, change cams and degree it in with the motor, with the heads already on it. Okay. When advancing and retarding the cam, Jessel makes it real easy. They not only have this adjustable gear, they have it written on here for you, advanced retard. Makes life a lot easier. Take our billet gear, we drill a hole, always have them drilled and ready for our builds, and put a 0 button in them. This particular gear set comes with a advanced retard feature on it. It says it's 4 degrees. Never assume, as I'll say, dot to dot is an assumption. So would be advanced retard. If you wanted to advance it 4 degrees, you might advance it 4 degrees. It might be 6, it might only be 2. So you still have to check it no matter what. Sometimes it's a 4 degree button advancing it. Sometimes it's a 4 degree button retarded in. So that's kind of why this is important. A big difference in a motor if it's 8 degrees retarded. Okay, Here we're going to demonstrate the hard stop method for finding TDC. We'll just gently roll the motor over clockwise. We'll see where it stops. Stops at 20. Okay. Now we'll go counterclockwise and we'll see where it stops. Stops at 19. So we need to split the difference. There. 19 and a half. Let's go check. Make sure that's what we wind up with. 19 and a half. So that should be perfect TDC. And we need to protect this pointer. We're now ready to set up our portion of this to start degreeing in the cam. I got a set of checker lifters here. I use light oil, in this case WD-40, because I want to make sure nothing affects these lifters going up and down. I'm about to set up my dial indicator, so what I'm going to try to do here is get the lifter at max height so that I can make sure my dial indicator doesn't bottom out. I'm going to use a push rod in this case. With that set up, I still have plenty of travel. This is a 2-inch dial indicator, so I'll have plenty of room. Most people will only have a 1-inch, so your amount of room will be less, but you need to make sure you got room on both ends, bottom and top, so that you don't get a false reading. Okay. We have plenty of travel there. There's the bottom. So nothing is going to give us a false reading from this standpoint. Okay, when we start degreeing in the cam, these are the numbers we're going to look for. Open at 50, close at 50, add these two together, then add 180. That will equal our duration at 50. We will then take that number, divide it by 2, subtract the open at 50 number, and then that will give us our intake center line. We will then go to the exhaust side of degreeing in the cam. Same procedures. We're going to check open at 50 plus close at 50 plus 180. Then that will equal our duration at 50. We will then divide the duration at 50 by 2, and then subtract on the exhaust side, we subtract the close at 50, and then that will equal our center line. Okay. We then take our intake center line plus our exhaust center line, add them together, divide them by 2, and then that comes up with the cam lobe separation. Okay, we now want to be on the back side of our lobe so that we can set the 0 on our dial indicator. And what we're going to be looking for is to come up, this is where the term 50 off comes from. And we want to make sure it stays on 0 until it heads to the clockwise or positive. Now we're coming up on 50, and then we'll come around here, and my degree in this case is, we're going to call this 30.5. Alright. The next number we're going to look for, which I had told y'all earlier, was we wanted to know, when I'm doing my build sheet, I wanted to know lift after TDC. So that's 50. That would be 100 thousandths. And now we're coming up on 10 degrees. So we're at 205. There's 300. There's 400. 494 lift. Okay, now we write that number down. Now we'll back up. We'll keep turning forward, clockwise. And there's 400, 300, 200, 100. And now we're going to get our closing at 50. Now we come to our wheel. This is where you use your black numbers for intake closing. It's clearly marked. It's a good thing about this degree wheel. 71, 2.5. We're going to do the intake numbers. Open at 50 plus close at 50 plus 180 will equal our duration at 50, in this case 283. There's your duration. Now we divide it by 2. We come up with this number, 141.5. Then we subtract the open at 50, which was 30.5, and that gives us an intake center line of 111. So making sure it stays on zeros and it starts to head toward 50. Just like with intake, this is a belt drive. We got to backload it. There it is, still 2 degrees backloading. Okay, coming up with 91.5. Okay. Exhaust is different from intake on the next step. Next step on exhaust, we'll be getting maximum load lift. There's 100, 200, 300, 485. That's the load lift, 480. Now let's find our lift at close. There's 200, 100, and we're looking for 50 coming up. Okay, we've got to backload it. Okay, and it is got 37.5. For the exhaust, we get the open number at 50, which is 91.5, plus the closed number at 50, plus 180, which equals 309, duration at 50 thousandths. We then take that number, divide it by 2, come up with 154.5. Then we subtract the close number at 50, which is 37.5, and we come up with 117 exhaust center line. Now to do your camshaft lobe separation, you take the intake center line, which was 111, the exhaust center line, which was 117, add them together, then divide them by 2, and you come up with a 114 lobe separation, which is why we're running the intake number, since we generally run 2 to 3 up, why we're running it at 111.